Let's construct our first model. We're going to be analyzing the bond market and the determination of interest rates. We'll imagine a demand and supply model for zero-risk bonds. And just like any simple demand and supply model, price is on the vertical axis, quantity of the thing being traded is on the horizontal axis. There is a downward sloping demand curve and an upward sloping supply curve. So what we'll imagine now is an initial equilibrium where the price of a standard bond is P0. Many factors affect the demand and supply for bonds, and we'll be talking about those factors later. For now, we'll just assume that the demand curve is what it is and the supply curve is what it is. One more thing. Remember, we talked about how the price of bonds generally, is inversely related to interest rates. That is the connection between this model and interest rates. To make the demand and supply model more concrete, let's think about a specific bond, and we'll use the most simple possible bond. A one-year bond, it gives a single payment of $100 at the end of the year, which means holding period return and yield to maturity are the same thing. Technically, this is a one-year zero coupon bond with a face value of $100. So buyers and sellers will agree on a price, and that means P equals $100 divided by 1 plus I, where I is the endogenously determined interest rate or yield in this little microeconomy. And we know the equation will hold exactly because we're assuming it's an efficient market. Efficient in this sense means there's no inconsistencies in prices that some arbitrager could exploit to make free money. Everything has to add up, and there's no waste, if you like, or no irrationality in this market. At this point, I'll take a little digression to talk about models. When we do the simple demand and supply model, the little diagram that you saw earlier, to somebody in the business of finance or accounting or a similar field, an equation and a diagram like the demand and supply diagram seems impossibly simplistic. It's not literally a description of the structure and features of a real-world financial market. To an economist, the demand and supply diagram and all that goes with it is not intended to be a literal description or photograph of how a market or a financial sector looks like. A model to an economist is like a story that attempts to capture fundamental forces and incentives and structures of interaction. It's not aiming to reproduce like a simulation the real world experience. So when we do demand and supply diagrams, we are attempting to look below the surface at the fundamental forces and the fundamental concerns that will determine the general trend of things like the price of bonds, interest rates, and investment, and behavior. This is a difference also in the motivation that economists have for studying finance and money and banking. The economists are not looking to train students to be prepared to perform on a day-to-day basis in the mechanics of trading or giving financial advice or reconciling spreadsheets. The economists are concerned with the big picture of how the entire sector functions. Is it functioning correctly to support the real economy? What should be the regulatory agencies' actions? What should be the areas of concern? And to a lesser degree, give some sense of the future potential for the financial sector to grow, develop, change. So that's a very different philosophy. Bottom line, don't be put off by a model that assumes the very simplest type of bond with the simplest type of equation. It captures the things we care about, like the inverse correlation between prices and interest rates. We don't need a complex model to explain that. While we're at it, as you will see in my lecture notes, I take a little diversion into discussing economic experiments. Just like a model is a form of story, so too an economic experiment in some ways is like creating a model. It's creating a story, except that we don't know how the story will turn out. So subjects, oftentimes students, are put in a situation where they have to make choices, and the choices are constrained by some sort of rules, and we design the experiment in such a way that we're going to learn something from observing the choices that the subjects make. Some of you are familiar with economic experiments. You're familiar with the ones that test strategic behavior in game theory type situations. Some of them test market behavior, where subjects are put into market-like situations. So an experiment is, in a sense, another way to model an economic question of interest, with the difference that the outcome of the outcome in the model is not going to be determined by math. It's going to be determined by the actions of actual, unpredictable human beings. By the way, the screen there shows the output from a particular kind of experiment created by Professor Bart Wilson, who is an incoming visiting Rasmussen Chair of Economics. In this experiment, the subjects were put into a situation of having a production economy, but no rules of exchange. The rules of exchange and trade had to be developed endogenously by the subjects, in this case students, through interaction. There is no external enforcement of property rights, for example. People can, in fact, steal from each other. So this little society had to create and figure out a way to enforce trading rules, property rights rules. It's an experiment that examines how societies and systems of relationships develop endogenously. You see the chat there. The chat, which is the means of communication, is not only a way for the experiment to operate, but it's also a way to track what's going on, how people are coming to a consensus. It's an experiment in how the rule of law evolves, how the rule of law develops in societies. Very unusual, very interesting subject. Well, back to money and banking in the next slide.